bioscience. Let's welcome Jeff Mullen.
Thank you. So I've been in research for 3 decades plus some, and luckily I've been a farmer for 2 decades as well. So I have 1 foot farming corn and soy for the most part, a little bit of a cattle operation. But otherwise, off the farm, my day job is in an R&D. So I'm very proud of being a farmer, working in research to develop products and to try and validate those for myself as if dealing with you individually. So hopefully several of you grow corn, soy, and wheat, and I want to introduce a new product in your toolbox, that's PeptiGrow. Okay, first I want to give you a few slides, 4 or 5, just highlighting, I think, the challenge of product validation, and not every company has a lot of integrity and a lot of trust. So I want to point out some analytical tools that help me to validate properly, but it also points out some examples where the system can be twisted and you can have products that don't work, that are still on the market. So on the left here is my assessment of what the status of marketing and sales is right now. Pretty much like going to a slot machine at a casino. All the music, all the bells and whistles, free drinks, they want you to buy their product and you're happy spending your money. What the farmer really wants is over on the right side, and that is you want a slot machine where you put in a coin and get back 3, 70-80% of the time. And if you do that, you'll find that farmer coming back, buying your product a lot, telling their neighbors, and you grow your market fast. So ultimately, here's where we want to be as best we can. And I want to highlight in the next 5 slides sort of what can we do to build proper experimental designs to adequately validate product performance. First, there's really little to no regulation on product testing and matching product performance data to claims. It's unregulated. If I was going to publish a research journal in a agronomy journal, you would have to have high quality data, you'd have to have appropriate designs, appropriate statistical analysis, and interpret that data. You'd send it to a departmental review, 3 to 5 faculty members in your department would review it. Hopefully okay it goes to the journal, and it goes out to a half dozen journal reviewers, and it gets reassessed. You make revisions, whatever. There's a system there to regulate and make sure that you're publishing high quality data. You can't publish no results and no treatment effects. So what I want to point out is over here, we've got company trust and integrity, low versus high, product claims, small versus high. And over on the left half of this panel is really low company integrity, small changes, potentially realistic, but they're rare. High changes, 10% or more, most likely unrealistic. I'll show you sort of why. High company trust, those that tend to spend the big bucks to do the testing appropriately, have a realistic chance of showing a 1 to 5% yield change, and and in cases where it's a high product claim, that there's a rare chance that they'll be able to do that. Again, it's all a matter of research budgets. So one of the things I want to point out is in this category, these are likely false positive results done unknowingly. And why I say unknowingly is a lot of sales and marketing groups do their own research trials, and they really don't have training in stats. So it's a type 1 error. Talk about it a little bit. Good companies show experimental design details, provide data summaries with statistical performance. And I'm here to tell you that data is the only thing you can use to show products are valid. Okay, I want to give you just an example. So if you had 1,000 corn plots in your field on one soil, same genetics, nothing changes, you would have a yield distribution from the smallest yield plot to the highest, and you'd have a frequency of those yields across those 10,000 or those 1,000 points. This is a bell-shaped curve. Most of the data lies within one standard deviation of the mean, but 33% of that data falls one standard deviation outside of that. And there lies why random selection can cause some false positives, and I just want to show that. So here's a case where the treatments are no different. And I want to run through 10 different trials using 1 rep, 3 reps, 6 reps, 21 reps. I just want to recap here. Type 1 error, false positive, treatment differences. You claim them when they are actually subsampling from the same data population. So over here in the column, we have 10 trials. 1 rep, 3 rep, 6 rep, 21 reps analyzed. Now you can't do stats on 1 rep, but you see the tremendous variability between the control and the treatment. Again, these are just arbitrary. What you're doing is asking the computer to randomly select one data point out of that whole distribution and call it a control versus your favorite treatment. Do it with 3 reps, and lo and behold, here's an example where you got significance at 0.07, p-value. If you go down to 6 reps, 2 of the 10 trials were also significant. As you move to higher reps, you don't see any significance. You can see the variability tightening around the mean, which is the dashed line, as you move to more and more reps. Now there are companies that may not understand false positive, and they may go in and take 2 or 3 of these trials that show significance, ignore all the trials that don't show a difference, and claim a product benefit, write up a brochure, and don't give you any stats. You don't know anything about the background of whether that product works or not. So p-value alone does not tell you everything you need to know. You need to know the experimental design and how many reps went into that analysis. Okay, so one of the greatest tools that I think is being missed is power analysis. Power is the probability that you will detect a specified effect size, like 10 bushel or 5, at a given significance level. You can use 0.05, 0.1, 0.2, whatever you want. But power allows you to determine how many reps you need to measure that desired effect at that desired alpha level. It eliminates, for the most part, your type 1 errors and your type 2 errors. Here's a real-world example. I use this a lot in research to predict what budget I need, to create the trial design I need to measure X bushel effect. So what I did here is just say, okay, on the column here is bushels to detect. This column here is the alpha level, very stringent, more relaxed, and basically using, this is a real world root mean square error, an estimate of the error in the model. That's roughly a 5.5 CV. And if you plug this into publicly available calculators, and I like this one here, and you can plug in 200 versus 202, the root mean square, and it will tell you, you want a p-value, you want a probability power of 80, and it'll tell you you need basically 386 reps to have a chance of measuring that 2 bushel effect with confidence. Okay, I want to move to our product. First, let's just define what would we like in a product. One is we want it to be robustly field tested. We would like it to work in both high yield and unfavorable environments. We want it to work on multiple crops and multiple genetic backgrounds within a crop. We'd like it to work under multiple types of application, whether it be foliar or in furrow. Obviously, we want it to work on multiple soils, and it's a good for the environment and supports sustainability. It needs to be safe, easy to use, can be a standalone product, or it could be tank mixed with herbicides, fungicides, or other fertilizer products. And ideally, you'd like it to come from a company that shares true product performance data and shares external designs, statistical output parameters that support the product efficacy. Very low cost effective and provides a return on investment of 3 to 1 or more. So those are the parameters. So I want to introduce PeptiGrow. It's a liquid mixture of beneficial amino acids and short chain polypeptides. So polypeptide is simply a protein that gets chopped up into smaller and smaller pieces. And so the average size of a peptide in our product is around 45 amino acids held together in a small chain or peptide chain. It's about 25% free amino acids. It's a grade 2001.55 for sulfur. So nothing standing out. It's not a replacement for your fertilizer program. It's an additive for your fertilizer program. Okay, it can be tank mixed, as I mentioned, or it can be a standalone product. Here's the take-home message that I want to provide the data to support in the next several slides. Provides a 3 to 1 or more return on your investment. Gives 2+ bushel in corn, foliar, or in furrow. Gives 1+ bushel benefit in soy and wheat, in furrow or foliar as well. Okay, the other thing I might point out is it's both physically and functionally compatible with 10 commonly used corn and 10 commonly used soybean herbicides. We have fungicide testing underway right now. I actually have the data, just haven't analyzed it. Might also point out our product is a great source of nutrients for microbes. And it has a very low suggested manufacturer price. So here's a critical slide, and this shows you the extent of data testing that we've done. Okay. So over here I've got the experiment type, foliar or in furrow, corn, soy, and so in the 3 years for corn foliar, we've got 59 trials, 480 reps, 3,800 total plots. For soy, 58 trials, 388 reps, 4,000 yield trials. In furrow, again, similar data points for the most part. In total, we have 13,320 yield plots in the data I'm going to show you. Roughly $100 a plot tells you right now roughly a $1.3 million investment in research just for the research of plot data. So I want to present, I think it's 5 slides. This is the 2-year average corn foliar results. And the way this is laid out is this is the standalone panel on the left. Our product with 2 gal of 624-6 is on the right. This is 0 rate. This is the control in yellow or so. In the green bars, 8 fluid ounces, 1632, and likewise over here. I'm excited to say that we get a stair-step dose response, upward of 3 bushel an acre benefit for our go-to recommended rate of 32 fluid ounces an acre. Even adding our product to 2 gallon of 624-6 in the foliar spray. For the control, we saw over the 2-year period a 1.3 foliar benefit for the 624-6 by itself. But when you add our product with 624-6, you get upwards of 1.2 bushel additive benefit. I give you the LS means tables, I give you the summary of data fit, I give you the fixed effects. Treatments separate out with a 0.02 p-value. Okay, moving to corn in furrow, we're seeing upwards of a little over 3 bushel benefit as a standalone product in furrow. This is no 5 gallon 624-6. This is just 1 quart an acre of our product. If you add our product to 5 gallon of 624-6, this is the control, no Peptigrow. We're seeing an additive benefit as high as roughly 2 bushel above starter fertilizer benefit of roughly 2 bushels. So comparing the 624-6 to the control gives you a 2 bushel benefit. Again, providing the data. This is based on 3 years, 10 states, 43 corn trials, 286 reps, and a little over 2,000 data points. Looking at our 2-year foliar effect in soy, we're getting upwards of a little over 1 bushel benefit as a standalone product, and likewise close to a half to 1.5 bushel benefit added to the 2 gallons of 624-6. Again, a little over 4,000 data points. The 3-year average of in-furrow in soybeans, which is not normally done, we are seeing basically no benefit from a starter fertilizer in soy, and I think that's probably a common response. But what you are seeing with our product is a benefit. So our product is not necessarily adding just a fertilizer. And I don't know what it's adding for the most part, other than the amino acids and peptides are giving us a clear yield benefit. It's hard to think that these are high yield fertility plots in the first place. And so we wonder a little bit whether we're feeding microbes. Again, this is done with a little over 2,000 data points. We did in 2021, 890 acres of on-farm strip trialing. Every field was significant. Our average benefit was 1.3 bushel an acre. I want to talk just quickly about wheat trials this year. We did 2 foliar applications, one at green up and flag leaf. Our control was water only. At the green up stage, I got 15 pounds of liquid UAN. And then our treatment was 32 ounces of NF20. By the way, that's a research product name versus our commercial name, Peptigrow. And then 2 treatments, 20 reps. We expect 260 reps. And I'll talk about the yield data. For the in-furrow, what we did is to coat the dry fertilizer. So 40 pounds of dry fertilizer, we coated that with our Peptigrow product, mixed that in with seed, and then planted our plots. Okay, here's the final slide. So significant both on the foliar and the in-furrow fixed effects. For the foliar, we're seeing a 1.2 bushel benefit. For the in-furrow, we're seeing a 1.5 bushel benefit. So I go back to what we look for in a product. In each of the cases, our sport card is a check mark for everything we would normally desire in a product. Again, I mentioned the take-home message. Peptigrow shows a clear yield advantage. It can be a standalone product. It can be tank mixed with herbicides, fungicides. Proven to be a greater or equal to a 3-to-1 return on investment. It's a great source of nutrients for microbes and a very low manufacturer's suggested retail price. I want to thank you for your time here today. Just pointing out, it's a new product for 2023. Encourage you to try it. Be sold in 2.5 gallon jugs or totes. We're looking for qualified farmers for more on-farm strip testing. And then we're also looking for distributors. If you're at all interested, have additional questions, you've got my contact info. So I'll be around this week. Happy to answer any further questions you might have.
All right, thank you. We're glad you're going to be here this week, too.